All right, if you're building anything with AI right now, you can't escape the word agent. It is everywhere. And honestly, it feels like a bit of a gold rush, right? New frameworks, new tools, they're popping up what feels like every single day. And while that's super exciting, let's be real, it's also incredibly confusing. So in this explainer, we're going to cut right through that noise. We're going to give you a clear map to this new AI agent landscape.
I mean, that's the big question, isn't it? You know you want to build these incredibly powerful, smart systems. But here's the thing. Picking the wrong foundation, oh man, that can be such a costly mistake. You could end up having to rewrite everything down the line. So, with all these options out there, how in the world do you choose the right one for your project? That is the core question we're going to tackle together today. Okay, so here's our game plan. First, we'll dive into that gold rush I mentioned. Then, we'll make sense of it all with 3 core architectures. We'll look at the big debate, what I'm calling the Great Divide. After that, we'll see how Claude's approach kind of changed the whole game. And finally, we'll land on the big question. What's your building philosophy? So let's jump in. We really are in a brand new frontier. The whole ecosystem has just exploded, and it's kind of settled around 5 major frameworks for now. And here's the tricky part. They all sound similar on the surface, but underneath, they have fundamentally different ideas about how an AI agent should even work. Okay, take a look at this. We've got the big players here: LangChain, Claude, OpenCode, OpenAI, and Google. Now, they all use the same buzzwords, right? They all talk about tools, memory, orchestration, but don't let that fool you. Their actual design goals are worlds apart. You've got LangChain on one end, which is all about being provider agnostic, and then you have something like the Claude SDK, which is all about deep integration. Every single one has its own unique philosophy, and that's what we're about to unpack. All right, so instead of getting totally lost in comparing every little feature, which would take forever, let's zoom out. Let's simplify. We can actually map this entire confusing landscape by just understanding 3 core architectural philosophies. Honestly, this is the key to making it all click. And here it is. This is our map. Think of it like this. On one side, you've got agent runtimes. These are all about giving you control. In the middle, you have model-native SDKs, which are really focused on letting the model be autonomous. And then, on the other side, you have the full-blown agent platforms. These are entire ecosystems. These are like the 3 main continents on our new world map of AI agents. Okay, first up, agent runtimes. The best way to think about these is pretty simple, actually. If your agent is a program, then the runtime is its operating system. Its whole job is to manage complex workflows, handle things when they crash, and this is the important part, give you explicit, fine-grained control over every single step. And the prime example here is LangChain Deep Agents. The core technology is something called LangGraph, which, it basically models the agent's entire job as a state graph. Think of it like a really smart flowchart. And the huge benefit, the key word here is durability. If your agent crashes halfway through some super complex task, no problem. It can just resume from the last checkpoint. It knows exactly where it left off. All right, next up we have model-native SDKs. And these, well, they take the complete opposite approach. This isn't a one-size-fits-all kind of deal. Think of it more like a custom-tailored suit, but for a specific AI model. They're designed to go deep, to expose the native reasoning loop of that one model, all so you can squeeze every last drop of performance out of it. And the poster child for this is the Claude Agent SDK. That's software development kit, of course. It's not trying to be some generic coordinator for a bunch of models. No way. Its whole purpose is to give you a direct line to the exact gather, context, reason, act, verify loop that makes Claude so incredibly good at what it does. You're basically tapping right into the model's native superpowers. And that brings us to our third and final category, agent platforms. Okay, these are the all-in-one, batteries-included solutions. Don't think of them as just a library you import. No. Think of them more like a complete IDE, an integrated development environment, but built specifically for creating, testing, and deploying agents from start to finish. So this is where you'll find frameworks like OpenCode, Google's ADK, that's their agent development kit, and the OpenAI Agents SDK. Their whole focus is to give you everything you need right out of the box. We're talking complete environments, often with client-server setups, ready for you to build and deploy. You'd go down this route if you want a fully managed experience, especially if you're building for serious enterprise-level scale. Okay, so we've got our 3 categories. But let's be honest, while they're all important, the really interesting, the most consequential debate happening right now, it's between those first two, the agent runtimes versus the model native SDKs. And this brings us right to the great divide, perfectly embodied by LangChain and Claude.
And this quote right here, it just nails it. It asks the fundamental question that these two frameworks answer completely differently. Should your agent infrastructure be model agnostic or model native? See, this isn't just about a feature checklist, it's a deep philosophical disagreement. Should you build a foundation that can work with any model, or one that's perfectly tuned for the absolute best performance from one specific model? And you can see the results of that philosophy right here. It's not abstract, it has real architectural consequences. Over on one side, you've got Claude's continuous session loop. It's simple, it's elegant, it's this repeating cycle. Then you look at LangChain's graph runtime. It's a much more complex, stateful workflow with defined checkpoints, branches for different paths. You can even have points where a human has to approve the next step. And this chart just drives that point home. You can see how that one core philosophical choice, agnostic versus native, just cascades down and impacts everything else. Look at the model strategy, agnostic versus specific. Look at persistence, how it remembers things. Is it checkpointing a graph or saving session files? That one decision at the top really does define the entire rest of the architecture. So if you boil it all down, here's the crucial difference. LangChain's philosophy sees agents as complex, distributed workflows that need to be managed and controlled. But Claude's philosophy? It sees agents as autonomous reasoning loops that just need to be unleashed. But here's a really interesting twist in the story. These frameworks, they didn't just evolve in a vacuum. Turns out, LangChain's newer designs were heavily influenced by the massive success of Claude's agent capabilities. Claude basically established a whole new baseline for what any modern agent framework has to be able to do. Yeah, by using it in production, Claude proved there were 5 specific capabilities that were just non-negotiable if you wanted to build truly complex agents. These became what we call table stakes, the minimum you need to even play the game. So any new framework, and that includes the newer LangChain deep agents, had to have an answer for all 5. It seriously raised the bar for the entire field. And so what are these 5 table stakes? Well, here they are. First, planning, breaking down a big, messy task into smaller steps. Second, delegation, the ability to spin up specialized sub-agents for specific jobs. Third, context management, being smart about summarizing long conversations so you don't lose track. Fourth, the file system. It has to be able to read, write, and edit files directly. And finally, guardrails. You need a way to intercept actions before they execute for safety. Any modern framework has to nail all 5 of these. Okay, so this all brings us back to you, the builder. Because at the end of the day, there is no single best framework. That's not a thing. The right choice for you depends entirely on your own building philosophy, and just as importantly, which trade-offs you're willing to live with. So let's make this super concrete. If you go with a provider-agnostic approach like LangChain, what do you get? You get incredible flexibility across more than 100 models and really explicit control over the workflow. But what do you give up? You give up that super tight model integration, and you might have to deal with more debugging complexity. Now flip it. If you go model native, like with Claude, what do you get? You get optimal peak performance from that one specific model. What do you give up? You give up provider choice, and you have to live with more constraints on your overall architecture. So when it all boils down, it really comes to this one question. It's a choice between flexibility and raw power. Are you going to build a future based on the flexibility to adapt to whatever new model comes along tomorrow? Or are you building a future based on harnessing the absolute maximum optimized power of a single incredible model today? Which future will you build? The choice is yours.